Today we're going to continue talking about graphs of sine and cosine functions. By the end of this video, you should be able to graph sine and cosine functions, including horizontal and vertical shifts, and you should be able to write the equation of sine and cosine functions. First, let's add to our knowledge of standard form of trig functions. So this works for sine or cosine functions. The absolute value of A is the amplitude, which tells us the height of the graph. B affects the period, which for sine and cosine, 2 pi over B will give us the period. C is going to affect the horizontal shift. So C over B will tell us how far we are shifting to the left or to the right. A positive value means we're moving to the right, a negative value means we are moving to the left. And D is our vertical shift. Positive value means we are moving up, a negative value means we are moving down. So we are going to sketch one period of y equals sine of x minus pi. Our amplitude is 1. The period is 2 pi divided by b, which is 1. So the period is still 2 pi. The quarter period is the period divided by 4, which is pi over 2. Our horizontal shift is going to be c over b, which is pi over 1, or just pi, so we are moving to the right. And our vertical shift is 0. The horizontal and vertical shift together are going to give us our starting point. So the point pi 0 is where we're going to start. We're going to label the axes the way we did in the last video. The y-axis, we're counting by 1/2, and on the x-axis, we're counting by pi over 4. So we are starting at pi 0, so I'm going to put a little box there. Since this is a sine function, if you remember the trick, you start at 0, and you go high, 0, low, high. So we're going to start at 0. Our quarter period is pi over 2, so every pi over 2 we are going to put a point. So we go high, 0, low, 0, and connect the points. So there we have our graph. Next, we have y equals cosine of x plus pi over 4. Our amplitude is still 1. The period is 2 pi over b. In this case, b is 1, so our period is 2 pi. The quarter period is 2 pi over 4, or pi over 2. The horizontal shift is c over b, so negative pi over 4 over 1, which is just negative pi over 4, so we are shifting to the left. And the vertical shift is 0. So our starting point will be negative pi over 4, 0. I'm going to label my axes the same way. And we are starting at negative pi over 4, 0. Since we have a cosine function this time, we're going to do high, 0, low, 0, high. Our amplitude is still 1, so high is going to be at positive 1. The quarter period is pi over 2, so we're going to put a point every pi over 2. And then connect the points. And that's our graph. Next, we have y equals cosine of 2x minus pi. The amplitude is still 1. The period is 2 pi divided by b, which is 2. So our period is pi. The quarter period is the period divided by 4, so pi over 4. The horizontal shift is c over b, so pi over 2. We're going to shift to the right. And our vertical shift is still 0. So our starting point is pi over 2, 0. I'm going to label my axes. And my starting point is pi over 2, 0. We have a cosine function, so we're going to do high, 0, low, 0, high. The amplitude is 1, so high is going to be at positive 1. This time our quarter period is pi over 4, so we need a point every pi over 4. And that's our function. Next, we have y equals cosine x plus 2. The amplitude is still 1. The period, since we do not have parentheses in this equation, c is 0, and the positive 2 at the end of the function is d, or our vertical shift. The period is going to be 2 pi, so the quarter period is 2 pi over 4, or pi over 2. Horizontal shift is 0, and the vertical shift is 2, so we're going up 2. Our starting point is going to be 0, 2. So I'm going to label my axes. My starting point is 0, 2. So I'm going to go ahead and extend my graph up to 3. Since we have a cosine function, we're going high, 0, low, 0, high. The amplitude is 1, so I'm going to go up 1 from my starting point. That'll be high. My quarter period is pi over 2. And when I say 0, I mean in line with the starting point. So you can see that this graph is just the regular cosine function shifted up 2 units. Since we changed our vertical shift, we can write out the domain and range for this function. The domain will always be all real numbers, or negative infinity to infinity. The range, however, is 1 to 3 for this function. Next, we have y equals negative 2 sine x minus 1. So here, our amplitude is 2, because remember, the amplitude is the absolute value of a, but since it's negative, we need to remember to flip our graph upside down. The period is still 2 pi because b is 1. So the quarter period is still 2 pi over 4, or pi over 2. The horizontal shift is going to be 0. Again, since there are no parentheses, that means that c is 0. And our vertical shift is -1. So we are shifting our graph down. So this means that 0, -1 is our starting point. So I'm going to go ahead and label our axes. Our starting point is 0, -1. Since our amplitude is 2, I'm going to go ahead and extend the y-axis down to -3. We have a sine function, so we have 0, high, 0, low, 0. But since our a value is negative, we need to flip this. So we have 0, low, 0, high, 0. So we're going to start in the box. The quarter period is pi over 2, so we're going to go over pi over 2. Then go low. Since our amplitude is 2, I'm going to go down 2. Then go over another pi over 2, back to the 0. Then go over pi over 2 and up 2 since our amplitude is 2. So there is the graph of our function. Our last graph is y equals 1/2 sine of 3x plus 2 pi. The amplitude is 1/2. The period is going to be 2 pi over 3. So our quarter period is 2 pi over 3 divided by 4, or 2 pi over 3 times 1/4, which is pi over 6. The horizontal shift is c over b, so -2 pi over 3, which means we're moving to the left. And our vertical shift is 0. So this means that our starting point is -2 pi over 3, 0. Since our period has a denominator of 3, we're going to adjust how we label our axes. The y-axis is going to stay the same, but on the x-axis we are going to count by pi over 6. So my starting point is -2 pi over 3, 0, which is here. We have a sine function, so we have 0, high, 0, low, 0. So I'm going to start in the box. My amplitude is 1/2, so when I go high, I'm only going up to 1/2. The quarter period is pi over 6, so I'm only going over 1 block. And there's our graph. I'm going to go ahead and write out the range for this function. That's going to be -1/2, +1/2. The domain will always be -infinity to infinity because you can continue cycling through the periods and go on forever. Our last problem, we want to write the equation of a sine function given that the amplitude is 3, the period is pi over 2, and the phase shift is 3 to the right. So, since the amplitude is 3, that means that a is either positive or -3. We have no way of knowing which it is. The period is pi over 2. We know that 2 pi divided by b tells us the period. So we can just solve this for b. If we cross multiply, we have 4 pi equals b pi, so b is 4. Phase shift is another way of saying a horizontal shift. So we're going 3 to the right. We know that c divided by b will give us our horizontal shift, and we just found out what b is. So we can plug that in. We get c equals 12. It does not say anything about a vertical shift, so we'll assume that d is 0. So then we can write out our equation. We're told it's a sine function, so we have y equals plus or minus 3 sine of 4x minus 12. And that's our equation.